let's start working on alkanes today. The first thing we need to know about alkanes, and we talked about it before, is that they are saturated hydrocarbons. Means they're a combination of carbon and hydrogens, all single bonds. So they're completely saturated, and their formula is CnH2n plus 2. This is the formula that you should never forget from now on, if you didn't know it before. So, if we have one carbon, N is 1, so how many hydrogens would you expect to have? 2, and plus 2 is 4. So the first hydrocarbon will be CH4. If you have 2 carbons, 2 times 2 plus 2 is 6. So the second alkane is C2H6. The third one, C3H8, and so on, C4H10, C5H12, and so on. So this is the important formula about alkanes that we need to know. And if you just want to give an example of an alkane, you can say, we just talked about this, you can say CH4, you can say C2H6, you can say even larger hydrocarbons, let's say C10, and then 2 times 10 plus 2, you're working with that formula, right, is 22, H22. Also, so far these are just a straight chain alkanes, right? Also, if we want to talk about cycloalkanes, alkanes can also be cyclic. Cycloalkanes. Their formula is very similar to that of alkanes with a small change. It's CnH2n. You may ask why? Why 2 hydrogens less? Because for making that chain, we need to remove 2 hydrogens. So the example can be this. So 6 carbons. Based on this formula, how many hydrogens do you expect? 12, right? If you have 5, how many hydrogens do you expect? 10. And feel free to count. These are the structural formula. So skeletal structures are. So each of these carbons must be connected to 2 hydrogens because each carbon must have 4 bonds around it. Okay, the next thing about alkanes, or in general about the organic molecules which are alkanes here, is how to show them. How to show them correctly in the space. So for example, for methane, there are 4 hydrogens, right? And so far, you know that skeletal structure is shown as this, right? But this image doesn't give you an idea of the 3D picture of the compound. How do you show the 3D picture? We normally show the group, which is hydrogen here, in the front on a wedge. So this shows front hydrogen. Normally the group, which is again hydrogen here in the back, is shown on dash. This is a back hydrogen. And doesn't matter if you draw it this side or this side, doesn't matter. The 2 other groups, one of them will be in the front, one of them in the back, and the 2 groups on the plane, so they are on the plane. If you have molecular models, feel free to make them with your models. In the next video, I'm going to use the models for you to show you the different conformations. So this is the actual shape form for a methane molecule with the 3D structure. So again, wedge shows the group on the front, dash shows the group on the back, and the two lines show the groups on the plane. How about ethane molecule? If we show it as CH3, CH3. So don't forget, two groups, one in the front, one in the back. So you show the front towards you, the one in the back far from you, one on the plane, and you need to show another one on the plane. Now, the difference between ethane and methane here is that we just have one carbon with 4 hydrogens, now you have 2 carbons. So the fourth bond is going to be the connection to the other carbon, right? And you have different options where to show the hydrogens, but just the only thing matters at this point is to show one of them on wedge, one of them on dash, and the last one on the line, on the plane. Okay, the bond angle, the bond lengths are not important for us at this point. You see 109 picometers, and for ethane is 153 picometers. Don't worry, this is not the focus of our study. So try to draw the 3D structure for propane when you have CH3, CH2, CH3. Try to work based on these. You just need to add one more carbon and 2 hydrogens in the middle, and don't forget the 3D structure. Okay. We talked about this concept, the next concept before, structural or constitutional isomers. These are, as you remember, these are the compounds with the same formula but different arrangement of atoms. So for example, if you want to draw the 2 constitutional isomers for C5H12, the skeletal structure, the first one is just a straight chain without any branches. That's the easiest. 1, 2, 3, 4, 5. And then let's have a branch. 1, 2, 3, 4, and we can have a branch here. If you count the total number of carbons and hydrogens, you will see in both of them you have 5 carbons and 12 hydrogens. So be ready for this type of questions. In the next page, page 2 of this study guide, you need to memorize the name of some of the alkanes. From methane, these 2 tables are not given. Don't expect them to be there as if like you are expecting the alphabets of a language given to you. So memorize the names of alkanes from methane all the way to decane. You need to memorize those names. But more important than that is to memorize the names of alkyl substituents. So this to be memorized. But how about branches? Or as we have in the book, alkyl branches. Do you remember we talked about alkyl groups before? Alkyl groups are any combination of carbon and hydrogen. Here, if our alkane, is methane, then alkyl group is formed by subtracting 1 hydrogen from your alkane. So your alkyl, the related alkyl from methane is going to be CH3. We put a dash here because it shows it's a branch, so it has to be connected to the rest of the molecule. We took one hydrogen out to provide an extra, not extra, one bond to connect the carbon to the rest of the group. If you have CH3, so this was methane, you have methyl, you have ethane. So what would be the formula? You remove one of the hydrogens, doesn't matter which of these carbons. So instead of CH3, you have CH2, CH3. And you remove A and E, you substitute it with YL. So if methane changed to methyl, ethane will change to ethyl. So far, we're dealing with two very simple alkanes and alkyl groups, so not a problem. When you go to propyl and butyl, you will have more options. So, look. You have memorized it from the previous table. This is propane, and we need to remove one of these hydrogens from these carbons, one of these two terminal carbons from the end. Okay, so you call it A and E changes to YL, propyl. And you may ask, what if I remove the hydrogen from the middle carbon? Then you will end up having same propane, still the same propane, but you're removing hydrogen from the second carbon. So the first carbon is still CH3, CH, CH3. In this case, you will call it iso. Basically, in naming, whenever we bring the ISO in the before the name, means that something is going on the second carbon. Okay? What is going on the second carbon here? The hydrogen has been removed. So we call it isopropyl. Okay. So far, it's still not very confusing. But with the butane, when you have 4 carbons, you have more choices. This is the butane, CH3, CH2, CH2, CH3. See clearly? All right, so this is butane. If you just remove hydrogen from one of these carbons, and you know this is a primary carbon, right? So if you remove a primary hydrogen, then it's easy, the same as what you had before. Butane will change to butyl, correct? But you see you have more options. The length of the chain is increasing. You will have more options to remove the hydrogens. Now, if I put one of the carbons on the second carbon and remove the hydrogen, I'm talking about another structural isomer of butane. If I change my butane like this, this is a constitutional isomer, right? And I still remove from this carbon. So what type of hydrogen is it? It's still primary hydrogen, right? I call it so you see I changed the normal butane, the long chain butane, to 2-methylpropane, to a constitutional isomer. I will start naming them in a minute. So I still remove a primary hydrogen. So I'm still working on the primary hydrogens. Remember, in the previous chapter, you learned about the type of carbon and hydrogens. So when you remove a primary hydrogen, but something is going on the second carbon. What is going on the second carbon? You have a branch on the second carbon, so you call it isobutyl. Same as isopropyl, something was going on the second carbon. What? A branch. So far these are the two branches you can make out of butane. You still have two more. We should have some. I'll try to squeeze them. One more. Let's take this one here and form I'll draw it here. Let's take a secondary hydrogen this time. So far we just removed the primary hydrogens, right? So let's remove a secondary hydrogen. It will be CH, and this is a connection because carbon needs an extra bond, another bond, not extra. So since this is the secondary carbon, then you call it sec-butyl. We do not write the whole secondary name, so you just call it sec-butyl. Sec and butyl are separated by a dash. Sec-butyl. And finally, if you work, so this one we made it from this, and now let's make another constitutional isomer from this compound. If I move this CH3 on top and remove the tertiary hydrogen, or let's just say we are removing the tertiary hydrogen. This is a tertiary hydrogen, right? Correct? Because it's connected to a tertiary carbon. Carbon is connected to 3 more carbons. So you will have CH3, C, CH3, and CH3. This would be the connection to the, let me draw it here. We'll have CH3. So by removing a tertiary hydrogen, we will have a tertiary butyl, or call it tert butyl. So they are all derived from butyl. If it's just a straight from one of the terminal hydrogens, which are primary hydrogens, it's simply called butyl. If it's removed from a secondary hydrogen, it's called a sec-butyl. If one of the carbons forms a branch and we still remove a primary hydrogen, we call it isobutyl. And if we remove the tertiary butyl, we call it tert butyl. You must memorize these by heart. You must know them by heart. They won't be given, and they are extremely essential in naming the compounds and knowing the name of the compounds. You're learning a new language. Language is organic chemistry. It's not possible to skip them. So try to know them by heart. And let's move to page 3 and work on some example just to determine the type of the branches. So as we go, I will name them. From the branch, this is connected to the skeleton, to this cyclic compound. So 1, 2, 3, right? 1, 2, 3, and they're connected from the end. So it is a propyl. Here you have 1, 2, 3, and 4. Why? Because we do not count this. This is the carbon on the cyclic compound. 1, 2, 3, and this is 4. And it's connected from the end, from a primary carbon, so it's just the butyl, normal butyl. Now, after that you have CH3, CH3, and CH3. Look, carbon here, first of all, the branch has how many total carbons? 1, 2, 3, and 4. So it's a derivative of butyl. But what type of butyl? Is it just a normal butyl? No. Determine the type of this carbon before it's connected to your compound. It's connected to 3 more, so it's a tertiary carbon, so it's called tert-butyl. And this is the easiest, just 1 carbon. It's derived from methane, so it's called methyl. So make sure you work on enough examples of these before we proceed to naming the compounds. Pause the video and practice as much as you want. Now we are getting to naming the compounds. I'm sure you all had naming of compounds in general chemistry too, but just in case you forgot, you got it so many years ago, let's review it. Iupac System, International Union of Pure and Applied Chemistry, sets the rules for naming compounds. The Iupac System is the combination of numbers and letters. Numbers and letters. So for naming alkanes, first, for example, if you have this, first we need to determine the parent chain, which should be the longest chain. You have them on page 3, so please go over the rules for naming alkanes. Parent chain is always the longest, and keep it in mind, the longest chain is not necessarily straight. It can be not straight, it can be curved. So parent chain 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Either way is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's not the longest chain. But if you have a branch, how do we determine which number gets the branch? We need to start from the end that gets to the branch faster. So if you number from left to right, 1, 2, 3, 4. And if you number from right to left, you have 1, 2, 3. So you need to start from right side to reach to the branch faster. 1, 2, 3, 4, 5, 6. You only have 1 branch. What is the name of branch when you just have 1 carbon and 3 invisible hydrogens? That's a methyl. So bring the location and the name of branch first. Which carbon is carrying the methyl group? The third one, right? What is it carrying? A methyl group. So between the name and number, you should always put a dash. 3-methyl is not correct. And there is no other branch, so we just name it as 6 for alkanes is hexane. So the ending shows that you're dealing with an alkane. Okay? Okay. What happened to my page? Okay. Second, I thought I had lost my page 4. Alright, page 4. You need to complete the table on page 4. Going from name to the formula. Let me do 2 of them for you, and you will work on the rest. The first one, 4. I wouldn't bother for the last 2 in that table. That's too early. If you still don't know how to name the alkenes and alcohols. 4-ethyl, 4-methyl heptane. So this name you will see the name of more than one branch. And when you have more than one branch, this one was very simple. For this one, when you have more than one branch, you have to bring their name alphabetically. E comes before M. So when you go from name to the formula, go backwards. Look at the end of the name that contains the parent chain. How many? 7. So put 7 carbons. 1, 2, 3, 4, 5, 6, 7. And what's going on? Seems like on carbon number 4, if we number them, on carbon number 4, seems like we have an ethyl group. 1, 2, because it's CH2, CH3, right? This is the skeletal structure for ethyl group. And there is a methyl group. Methyl group, we just need a line because this shows CH3. Okay, feel free to draw either a skeletal structure or line bonded structure, but in the exam you need to be prepared for any type of question given. And the second one is 3-ethyl hexane. 3-ethyl hexane. So again, from the end, here you have 7 carbons, here you have 6 carbons. 1, 2, 3, 4, 5, and 6. On the 3rd carbon, you have an ethyl group. 1, 2, CH2, CH3. So the groups can be on top or at the bottom. At this point, doesn't matter. So the next 2 compounds on page 4 table, don't worry about them. One of them is 1-bromo-2 pentanol, and the second one is, the last one is 4-methyl-2 heptene. Don't worry about them. These are the namings for an alkene and an alcohol. That's a little bit too early for you, so take it easy. Just work on naming alkanes. Let's move towards the next practice on page 4, which is, I'm not going to work on all of them, just 2 of them. The rest you can work. I will work on B and F. Alright, B says it's 4-ethyl. There are some points in this too that I want to mention. 2 and 2 dimethyl hexane. So you might say, okay, you told me to bring the name of the branches alphabetically, but how come you're bringing E before D? Di is a prefix. Di, tri, tetra, they are prefix. So we do not consider them for naming. What we go with is the M in methyl and E in ethyl. So which one comes first in alphabet? E or M? E. That's why you see ethyl first. So again, going from name to the structure, look at the parent name, hexane. Hexane means 6 carbons. 1, 2, 3, 4, 5, and 6. What's going on? Let's number it. And then on the 4th carbon, there's an ethyl group. Ethyl group needs 2 carbons, 1, 2. And on the 2nd carbon, there are 2 methyl groups, so that's why you have to mention di. If you had 3, you would say tri. I will give you an example of drawing such a structure. And for F, you have 4 isopropyl, 3 methyl heptane. So here you might say, okay, if you go with what you just said, P is after M, but in isopropyl it's the same, it's one word. So we consider I versus M. Iso is one word, the rest are different. So a heptane has 7 carbons. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Isopropyl. Isopropyl is a propyl but is connected from the 2nd carbon. You remember I told you when we say iso, something is going on the 2nd carbon. In case of isopropyl, isopropyl is connected from the 2nd carbon. Or you can see it as this. 1, 2, 3, 4, 5, 6, 7 heptane there. Or you can, you might see it as this. This is the same. This is CH and CH3, CH3. This is the more correct way for a skeletal structure. I drew it this way to show you what I mean. So there's an isopropyl on 4th and there's a methyl on the 3rd carbon. So in order to name, let's say we want to name this compound. Let's say which way is closer to reach to the first branch. 1, 2, 3, 4. 1, 2, 3, 4. That's the same. This is methyl. And these are ethyl, right? Alright, so which one comes first in alphabet? Ethyl. But if I name a number from left to right, 4 will be ethyl groups. If I name a number from right to left, 4 will be 4 methyl groups. We have a tie, we need a tiebreaker. What would be our tiebreaker? E, which comes before M. So let's start. What do we see on the 4th carbon? 2 ethyl groups, right? How do I mention 2 ethyl groups? Diethyl, right? But I have to also mention the number twice. If the groups are on the same carbon, please make sure you bring them twice. 4 and 4 means both of them on 4. Diethyl. What else do we see? A methyl. Where? On the 7th. 7 methyl. And what is the length of the chain? 10, which is a decane. Don't forget, between every number and letter you put a dash, and between each two numbers you need a comma. So if you are bringing di, you need to have two numbers. If you have them on different carbons, like let's say you have this, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, yeah, the same. 1, 2, 3, 4, 5, 6. I numbered it from left to right because it reaches to the first branch faster. What are your branches with two carbons? Ethyl, right? Where are they? Are they on the same compound like the previous example or different? Different. Where? On the second and the third carbon. So 2 and 3. How many ethyl groups? 2. And do we have any other branches? No, and 6 carbons is hexane. So no matter if your same groups are on the second carbon or on different carbons, if you have more than one branch of the same type, you definitely need to mention the locations of the branches accurately. Otherwise, you won't be able to draw the structure. Okay, this video is getting too long, so let me break it to 2. The next one will be the continuation of naming these alkanes and naming also naming cycloalkanes. Make sure you have enough practice and then start the second video.